Okay, welcome back. In this lesson, we're going to talk about section 6.3, calculating probabilities of events. Probably not counting them down, but there's only one more lecture after this one. Okay, we'll start out, and this is kind of basic. We talked about this last time, but experiments with equally likely outcomes. So in the intro, if we're rolling a single die, each outcome is equally likely. So that means you could have a 1, 2, 3, 4, 5, or 6 on the die. You can get any one of them as equals there, as long as it's a fair die. Just like if you're flipping a coin, heads or tails. So the probability of each outcome then would be 1/6, since there's 6 of them, 1/6 for each one. So let's say that we want to find the probability of getting an odd number. The probability of getting odd would be the probability of 1 plus the probability, that should be a 3 there. So I got the probability of 1 plus the probability of 3 plus the probability of 5. They're all 1/6. That's 1/6 plus 1/6 plus 1/6, which is 3/6. On Lord's terms, that's 1/2. Or you could say, got a little formula down here in the blue, the probability with equally likely outcomes, you could simply take the number that's in the event. So in this example I had up here, odd, there was 3 of them that were odd out of 6 total. Okay, and a lot of times I've said this before, I like to think of probability as good over total. So if I was rolling a die and wanted odd, there's 3 odds. That's 3 good. But there's 6 things total that could have happened. So 3 out of 6. So using the formula, there's 3 ways of getting an odd number, and there's 6 outcomes total in the sample space. So the probability of an odd would be 3/6 or 1/2. And sometimes I like to think this is good over total. That's what I put right in here. So we kind of thought when we think up here and we said, okay, there was 3 odd out of 6, you're thinking logically. And as long as it's equally likely outcomes, then you can think that way. Now, this is an easy example. A lot of times finding the number up here or the one down here, that's where we use some of the techniques that we learned in chapter 5. Okay, let's move ahead. So here's an example. It says selecting balls from an urn. An urn is, I don't know, it's a math. They use it in math, but probably goes back to the Greek days. But let's say we had some balls in the urn, and there's 8 balls altogether, an urn contains 8 white balls and 2 green, so that's a total of 10. Okay, and we're going to take a sample of 3 balls. We want the probability that the sample only contains white balls. So what we want the probability of getting 3 white. Okay, so we're going to set up this fraction. So my top number, I want 3 white balls. How many white balls are there? Well, there's 8. 8 white balls. So I could pick different white balls. How many different, this would be a combination problem because order is not important. That's a combination of 8 picking 3. Now, the second part of this, I probably should give you a formula, but I think I'm just going to not, and you'll learn it this way. So there was 3 white. How many green are we going to have? Okay, there's 2 greens altogether, but I don't want any of them. So out of the 2 green ones, I'm going to pick 0 of those. So this is for your white, that's for your green. And then the total, that's a combination. There was 10 balls altogether, and I'm picking 3. And that gives you a little formula. I'm going to point out something here. This is how you know if you're doing it right. Notice the first number here is an 8. The first number here is a 2. And the first number here is a 10. 8 plus 2 equals 10. And if you look at the second numbers, it's 3 plus 0 equals 3. Okay, so now what are those numbers? A combination of 8 picking 3 is 56. You can do the combination or whatever on that. Combination 2 picking 0 is 1. And on the bottom, a combination of 10 picking 3 is 120. So when you put all that together and put it in lowest terms, that ends up being 7 over 15. And I think we're just going to leave our answers in terms of a fraction. It works out a little bit easier for you. So what we did, the top number again was the number of possible ways we could get 3 of the white ones, and the bottom would be out of all 10. Okay, so let's go to the second part of this. What's the probability that the sample space contains 2 white and 1 green? So the probability, 2 white plus 1 green. So for the white, there are 8 white, and I'm going to pick how many? 2. And then for the green, there was 2 green, so it's a combination. Out of those 2, I'm going to pick 1. Combination of 2 picking 1. And on the bottom, it's a combination of, I've got 10 balls all together, and I'm picking 3. Notice you got 8 plus 2 gives you 10, and 2 plus 1 gives you 3. So if I put the numbers in there, combination of 8 picking 2, I've already done this, so streamline a little bit, that's 21. And a combination of 2 picking 1, that's 2. And the bottom number is still 120. So 2 times 21 is 42 over 120. And that's going to end up being 7 over 20 for your final answer. Okay, so what you see in this example, we used what we learned on the other page as far as taking the number of good over the number of total, but trying to calculate how many you have, well, it's a little bit harder. Now you use permutations, combinations, and the counting principle. You're using common sense is what you're using. Okay, let's go to the next one. A bin in the hi-fi department of Building 20, which is a bargain outlet, big box store, contains 100 blank CDs, of which 10 are known to be defective. If a customer selects 6 of these CDs, determine the probability that 2 of them are defective. So we want the probability of getting 2 that are defective. Now, if 2 of them are defective, what about the others? Well, they're non-defective. How many will there be? Well, there's 6 total. So if 2 of them are defective, that means I'm going to have 4 that I'll just put not defective. Okay, so of the defective ones, how many defective did we have altogether? 10 were defective. So that means a combination out of the 10 that are defective. There's 10 of them in there. I'm going to pick 2 of them. Okay. How many are not defective? Well, there was 100 altogether, so 100 minus 10, this would be a combination of, that number is going to be 90. Okay, we're picking 6 altogether. 2 are defective. That means you're going to have 4 not defective. And your bottom number is a combination of, there's 100 altogether, and we're picking 6. So see how the numbers come together. Take a look at that. Make sure you understand what's going on. So, Combination of 10 picking 2, that's not too bad. You could actually calculate that kind of in your head. I can, or at least easy computations. This one over here is a very big number. That's 2,555,190. And the bottom, a combination of 100 picking 6, is 1,192,052,400. Now, if I calculate all that out, I'm going to get a fraction that probably isn't going to make sense. On problems like this, it would make more sense to write as a decimal. So if you calculate all that, that's going to be 0.965. And we'll leave our answer like that. The harder problems, you're going to write it in terms of a decimal. Okay, so if you're doing this on your calculators, even the TI 83s, which are fantastic, sometimes when you plug in a combination of 90 picking 4, and then you hit the enter button, it'll say an error message. It'll be a number so big that you can't write down. So if you have that problem, you can do it like this. You can do the combination of 10 picking 2, but don't hit enter. Hit times, and then do the combination of 90 picking 4. Then hit divide, and then combination of 100 picking 6. And once you have all that, then hit the enter key. So you won't hit the enter until the end. So if you plug it in, it's going to look like this. You're going to go 10, and then you're going to go the combination, and it'll say NCR 2. You're going to go times, and then you're going to go 90, combination NCR of 4 divided by 100, combination NCR 6, and then you're going to hit the enter key. And that'll give you your answer all at one time. It'll give you a decimal. It won't give you a fraction. So if you run into a problem where the numbers get too big, that's how you get around that. Okay, that's page 2. Okay, it looks like example 3 and example 4 I've already got worked out for you. So I'm going to let you look at that for a second, and I'll talk through it. Okay, so let's look at example 3 first. Selecting students. A professor is randomly choosing a group of 3 students to do an oral presentation. In her class of 10 students, 2 are on the debate team. Now, in your mind, you're already thinking, okay, if 2 are on, how many are off? There's 10 altogether, so there's 8 that are not on the debate team. What is the chance that the professor chooses at least one of the debate students? Okay, so we really have 2 problems. The problem says it could be 1, so we've got to calculate the probability of getting 1, which is kind of what I did right here. And we have to find the probability of 2. So since it's either 1 or 2, we're going to add those numbers together. No. That's a different problem. I must have miscalculated. Let's start that over again. Oh, it says either 1 or 2. Okay. In my mind, I was turning things around. So you can see what I did. In this part right in here, that's the probability of getting 1. It was a combination. Okay, so there's 2 debate people. We're picking 1. There's 8 that are not debate people. We're picking 2. And on bottom's combination, 10 picking 3. So you get 2 plus 8 gives you 10, and 1 plus 2 gives you 3. And then when you come over here, this is the probability that you're going to get 2 of them. So out of the 2 debate people, you're going to pick 2. So that's a combination of 2 picking 2. And out of the other 8, you're going to pick 1 that's not on the debate team. So a combination 8 picking 1. And the bottom still a combination 10 picking 3. So you can see what we got here. We got 2 times 28, which is going to be 56. And 1 times 8 is 8. The bottom number is 120. So 64 over 120. A fraction in lowest terms is 8 over 15. And that's okay to leave that as an answer. Or if you prefer, you can write that as a decimal. I think that's actually 0.5333 and so on. So where you round off really is not important. Usually rule of thumb when you get into statistics is 4 decimal places. We're not there. Okay, example 4, I've got that one done also. Medical screening. Suppose that a cruise ship returns to the United States from the Far East. Unknown to anyone, 4 of the 6,000 passengers have contracted a rare disease. Suppose that the Public Health Service screens 20 passengers selected at random to see whether they have the rare disease. Suppose, let's see, just lost my placement. To see whether they have the disease is present aboard a ship. What is the probability that the presence of the disease will escape detection? So that means not getting it. Well, okay, so that means the 4 passengers, there's 4 passengers that have it, so we don't want to get any of those. So that means a combination of 4 picking 0 times a combination. Now, they're picking 20 altogether, so I got 4 of them here. That means 16 have to be here, and out of the 16, 4 of them cannot have the disease. No. Let's try that again. I don't know what I had there. I think I messed this problem up. Probably miscopied something. So on top, when you're talking about how many do not have the disease, okay, we want to get out of, let's see. So 4 of the people have it. So out of those 4 people that have it, that's a combination of 4 picking 0, because we want to escape detection, times a combination of, well, there's 6,000 total, so that means this is going to be 5,996 that don't have it, and we're going to pick 4 of those. And on the bottom, that's a combination of 6,000 picking 4. 4 plus that big number gives you 6,000, and 0 plus 4 gives you this. Okay, now I'm going to get my calculator out. And I'm going to do the whole thing. So I don't know if you can see this. I'm going to take 4 math combination 0 times 5,996 math combination 4 divided by 6,000 math combination 4, enter. And that number is, and I'm going to put it down here, .997, and then I'm going to round that off to a 3 right there. So there's a pretty good chance it will be undetected. So this is for those that had the disease. So out of those 4 people, we did not want to choose any of those because it was undetected, which means out of the other 5,996 people, we're going to pick any 4 of those. And on the bottom, we had 6,000 total, and we're picking 4. And when you plug all that in your calculator, you get .9973. Okay, what's next? Okay, let's example 5. Rolling a die 5 times. A die is rolled 5 times. What's the probability of obtaining exactly 3 4s? Okay, so if you can imagine, I'm going to draw something here. Out of those 5 spaces, because we're going to toss the die or roll the die 5 times, we want to get a 4 3 of the times. So let's just say I had a 4 here and a 4 here and a 4 here. That's 1 out of however many. So we're going to pick, that's a combination, out of the 5 spaces, I'm going to pick 3 of them to be a 4. Okay, so really I only have 1 choice for each of those, not 4, but 1. How many choices do you have for this blank here then? Well, it could be anything but a 4. So that means you have 5 choices, and the same thing here, 5. So your top number, it's a combination of 5 picking 3. That decides what blanks it's going to go in. And then you got the 2 5s. Then the bottom number, when you think about how many different possibilities could you have? Well, you could have 6 on the first, 6 on the second, 6 on the third, 6 on the fourth, 6 on the fifth. That's 6 times 6 times 6 times 6 times 6, or 6 to the 5th. Then when you do the math, on top you get 2,500, on the bottom you get 7776. And this is a good one. You probably would write this as a decimal, so 0.3215. Okay, and let's go to my last one. The last one incorporates the complement rule. We've talked about this before. So if E is the event and this is the complement, then if I want to find the probability of E, that would be 1 minus the probability of the complement. You know, it's just like if I said the probability of a 4 is 1 over 6, if I'm rolling a die, so 1 over 6, the probability of not getting a 4, 1 minus 1 over 6 would be 5 6. You can think of it that way. Now we're going to use this on the last problem I have. Call this the birthday problem. You've probably been someplace and this topic has came up if you have people there. Okay, a group of 5 people is selected at random. What is the probability that at least 2 of them have the same birthday? And we're considering 365 birthdays in a year. We're not considering leap year or anything like that. Okay, so give me a second here. Okay, so we're going to use that complement and we're going to find the probability of not coming up with the same birthday. So the probability that it's not going to have the same birthday, well, think of it like this. On the bottom, just like that other one where I had 6 to the 5th, there's 365 days in a year, so that's 365 different birthdays. So that number is going to be raised to the 5th. 365 times 365 times 365, and do that 5 times. Now your top number, if it does not repeat, your top number is going to be 365, you go to the first person, how many different birthdays could they have? 365. But once they take a birthday, since you cannot repeat, the next person only has 364 choices. And once they take a birthday, the next person is only going to have 363 choices. And the next one's going to be 362. And the next one's going to be 361. There's your 5 people. Okay, so I'm going to calculate that. So I'm going to take 365 times 364 times 363 times 362 times 361. Make sure I got in there right. Okay, I'm going to hit enter. No, I'm not going to hit enter. That's going to be a really big. Let's see what happens if I hit it. Yeah, so I've got a number in here. I don't know if you can read it. It's 6.30 and a bunch of numbers. And then it says E12. If you don't know what that means times 10 to the 12th. So it's in scientific notation. That's a really big number. So rather than doing that, I should have, and I still do it, I'm going to hit divided by. And then I'm going to take 365 raised to the 5th. I'll hit enter. This should give me a decimal. So that's going to be 0.9729. Round it off. Now that's the probability of not getting the same birthday. Now if I wanted at least 2 of them, that would be the complement. So the probability of at least 2 have the same birthday, that would be equal to 1 minus this number here using the complement rule, 9729. Yep. So when you subtract that, that should be 0.0271. That's the probability of having at least 2 people the same birthday. Probably thought it was higher than that, but it's not. Okay, so this is a lesson. I kind of use this same formula over and over again, good out of total. And we also use combinations, and sometimes you're going to use permutations or just the counting number or just logic, like here. It was 365 to the 5th. You know, last chapter I would have said, well, how many you got total? And I would have written 5 blanks, and each one of those would have been 365. And you multiply that, and that gives you this. And the top number is like I had here. What if I would have put blanks? And you would start with 365, and then you can't repeat, so that's 364, and you can't repeat, so 363, 362, 361, you're going to multiply this. That's where the logic came from, those numbers up on top. So these problems are a little more difficult. You've got to be a good thinker. You got to think logically. And this video, you may want to watch a couple times to make sure you understand what's going on. Okay, that takes care of section 6.3. We've got one more section, and I'll probably have that in a couple days to you.